Good day, everyone. Welcome once again to our lecture for today. So, today we are going to discuss more on the relationship between the velocity as a function of time and the acceleration as a function of time. So, our focus for today is for the interpretation of the relationship between the velocity v sub v of t and the acceleration a of t. Okay, so we have here an example. This is an example of what we had discussed in our previous videos about rectilinear motion and also the motion along a line. So for example, we have a particle that moves along a coordinate axis in a positive direction to the right, and its position at time t is given by s of t equal to t cubed, or t to the power 3 minus 4 times t plus 2s. And we are asked to find v of 1, or the value of the velocity at t equal to 1, and also the acceleration t equal to 1, and use these values to answer the following questions. So the questions are: letter A, is the particle moving from left to right or from right to left at t or time t equal to 1? Second question is the particle speeding up or slowing down at time t equal to 1? Okay, so this is our sample problem. So first we need to write down what are our givens. Right, so in our problem we are given the function, the position function, given as s of t equal to t cubed minus 4 times t and plus 2 times s. And we are required the following. So we are required to find the value of the velocity when t is equal to 1, and also the acceleration, the value of the acceleration when t equal to 1. And we are also asked the following question, class, that for letter A, is a particle moving from left to right or from right to left? So it means that we need to determine the direction of the movement of the particle. Okay, so direction of the movement of the particle. Okay, so we are asked to find out whether the particle moves from left to right or from right to left. And then for B, is the particle speeding up or slowing down at time t equal to 1? So we need to determine what happens. What happens to the particle at t equal to 1. Time t equal to 1 second, for example. Okay, so for our solution, we need to first find, or we begin to find Vt. So we will start by finding Vt, or the velocity, and At. Okay, so we have to find Vt and At. So from our given, we have S of t equal to t cubed minus 4t plus 2 times s. So therefore, s prime of t equal to 3t squared minus 4. So 2 is a constant, s, so that is also a constant, so derivative of the constant, so that is equal to 0. Alright? But what is s prime of t? So derivative of the function s, that is equivalent to, so our s prime of t equal to v sub t. Alright, so therefore we have v sub t equal to 3t squared minus 4. Alright, and we need also to find a of t. So v sub t, or v of t, is already done. So this is done. So we need to find a of t. So we know that if you take the derivative of this, so we have v of t. So when you take the derivative of this, so v prime of t, so what is the derivative of this? So that is 6t, right? And we know that v prime of t is equivalent to a of t, meaning the derivative of the velocity is the acceleration. So therefore we have a of t is equal to 60. Okay, now t equal to 1, so maybe it's 1 second. So at t equal to 1, so we have v 1, meaning at t equal to 1, so the velocity at t equal to 1 is equal to, so from this expression, so we have 3 times t is 1, so 1 squared minus 4. So v of 1, or the value of the velocity at t equal to 1 is equal to, so 1 squared is 1 times 3. 1 squared is equal to 1 times 3 equal to 3 minus 4, so this is minus 4. So our v of 1 is equal to minus 3. minus 4. So therefore, we have our v that is less than 0. So that's negative, right? How about our a of t? So we'll solve for a when t is equal to 1. So a1 equal to 6 times t is equal to 1. So 6 times 1. So a of 1 is equal to 6. So we can say that our acceleration, our a is greater than 0. Okay, because a is positive, so greater than 0. Alright, so we have solved our at. Now we have determined our v1, which is equal to negative 4, and we can see that this is less than 0, negative. Okay, then acceleration is greater than 0, so that's positive. So what can we say, no, for how will you answer our a? So what is our answer for a? Okay, so for our a, what is the direction of our direction of the movement of our particle? So since this is negative, our v of 1, or the value of the velocity at t equal to 1 equal to negative, so v is less than 0. So we can say that for our a, our answer here is the particle is moving from, so we can say that the particle is moving from right to left, from right all right. Now how about b? So what happens to the particle at t equal to 1? So we can say that since, okay, so for a we can say that since the value of the function v, velocity, is less than 0 or negative, then the particle is moving from right to left. Here, since v at t equal to 1 is less than 0, and a at t equal to 1 is greater than 0, then we can say that the acceleration, the velocity and acceleration are acting on the opposite direction. Okay, so since v at t equal to 1 is less than 0 and the a acceleration at t equal to 1 is greater than 0, so we can say that the velocity and acceleration are acting, they are acting in opposite direction. Okay, so acting in opposite direction. So in other words, the particle is being accelerated in the direction opposite to the direction in which it is traveling, causing the magnitude the magnitude of the velocity to decrease. Okay, so since v at t equal to 1 is less than 0 or negative, and acceleration at t equal to 1 greater than 0, then the velocity and acceleration are acting velocity and acceleration acting in opposite direction. So this scenario tell us that the particle is being accelerated in the direction opposite the direction in which it is traveling. So it causes causing the magnitude causing the magnitude of the velocity to decrease. So therefore we can say that the particle is, what do you think? The particle is slowing down. Okay, so the particle is slowing down. All right, so that's all for this problem. I hope you understood this one. Okay, so this is the solution, class. Okay, so if you have any question, just comment, provide your comment, or you just send your message to our group chat. Thank you very much. Have a nice day and stay safe and healthy always. God bless. Bye.